Welcome, everyone. Glad you're here. You guys excited for I/O? Yeah. Great. Well, I'm going to introduce the team. My name is John Stuppy, and I'm joined by John Buchanugan, my colleague on the Google Wallet Instant Buy team, as well as Jesus Shin, Director of Engineering and lead Android developer for The Fancy, one of our first initial integration partners of Google Wallet Instant Buy. Today, we're discussing building compelling m-commerce experiences on Android. So let's get started. As you heard earlier today, there are 900 million Android devices in the world. And what are people using these devices for more and more? Shopping. But it's not as easy as just having compelling products and services to get users to actually convert on your m-commerce applications. We find three big challenges. The first, discovery. How do people find your applications and products? How do they get excited about them? Then, when a user likes your application, how does she tell you a little bit more about herself and sign up for your application so that you can then tell her about upcoming product promotions and other offers? And finally, when she finds something she likes, how does she pay for it? Now, we find that the last two challenges here are entirely within your application, but they're large friction points due to mobile forms and other causes of pain that lead to a high mobile cart abandonment rate. And that's what we tried to solve with Google Wallet Instant Buy. As announced earlier today, Google Wallet Instant Buy is a small library that's part of Google Play Services, available on every device with the Play Store. Now, this means that a user with Google Wallet can make faster checkouts of physical goods and services in only a few taps on their phone. Further, as a merchant, the integration is very lightweight. Google Wallet sends your application a usable proxy card, complete with expiration date, CVC, billing address, as well as the shipping address that the user would like those items sent. Because we're using a virtual proxy card, the user is secure in knowing that their physical real data cards are not being sent. And further, it's free for merchants and consumers, so it's great. So in creating the Google Wallet Instant Buy app, we focused on three major areas of concern for users in hopes to avoid mobile cart app abandonment. And we'd like to share some of our techniques and tips and tricks that we've learned with you and ways that you can improve your own applications. We focused on mobile-friendly forms, reducing latency, and improving security and privacy for our users. So how many of you have ever been in an application, you've added items to your shopping cart, you go to checkout and have seen very lengthy forms asking you to sign up, asking for credit card information and shipping information? And you see these forms, and have you ever said, I don't have time. I'm on the go, I'm using an Android tablet or a phone, I just can't do it. And so you bailed on the transaction. So we tried to focus on making that interaction as smooth as possible. And while returning wallet users will be able to complete a checkout process on your application in 2 to 3 taps, new wallet users will experience a sign-up flow. So we've tried to optimize that as much as possible using mobile-friendly forms. So let's show how that's done. So I'm a new user using Google Wallet, and I'll say, buy with Google Wallet. And as I'm a new user, Google Wallet's going to ask me for some information. So the first piece is the credit card number. So I'll get out my credit card, and I'll start typing. And as we type, we see that we're doing real-time formatting of the card number, so that if I were to make a mistake, I could correct it very easily because I'm following along as I go. And when I do make a mistake, we alert the user right away using simple client-side checksum algorithm known as the Loon algorithm that the card is invalid. So I, as the user, can now correct this card while the card is still out on the table, and it's still fresh in my mind at what I'm doing. So I'll go back, and I'll correct the card. Now, it's a little hard to see on the screen, but we were able to auto-advance from the credit card field to the expiration month because we knew that the user had completed the credit card. Now, this allows me to simply follow along with the credit card data that I see and continue my form. Now, by auto-advancing from field to field, we reduce the need for the user from having to find the next key, or worse, hiding the keyboard, scrolling to the next field manually, and tapping into it. And again, this is just to ease user friction and help users get through the form faster. So now I'll fill out my name. And continue. And now we're at the always troubling billing address. Now, addresses differ from credit cards in that they're well known to the user or myself, but they are difficult to type out. There's many fields, they come in various forms, and they switch from letters to numbers all the time. So we've integrated this logic to be able to provide very fast help by using the Places API from Google Maps. So right now we're at 747 Howard Street here in San Francisco. Now, if you're typing 747 and the letter H, we see that our first result is where we are in our required billing address. So rather than type all those details out, I can select the address, it fills out the form for me, and I can continue on. Now, we don't have an apartment or suite, so I'll just scroll down. Now, for phone number, this device does not have a cell network, so there's no phone number tied to it. If it did, we could pre-fill that. So we'll just fill it in. And I want to use this as my shipping address, and I want to use Google Wallet to pay for future purchases on this merchant. So I'll continue. Now, in just that time, we have signed up for Google Wallet and continued through our checkout process, saving the user time now and later. So let's show how we did some of these features. The first was our ability to auto-advance from field to field. So to do that with our credit card, we needed to know when the credit card was complete and also when it was valid. So here's a very simple implementation of this interface for credit cards. And we'll say that a credit card is complete if it has at least 15 digits. And we'll say that a credit card is valid if it passes our Loon algorithm. And now if it's valid, we want to clear any errors on the text field and return true. If it's not valid, we want to mark an error on the text field for user action and return false. So how do we tie this into our application? For every field we want to enable auto-advance, we first add a text watcher so that every time the text changes, we can perform three actions. The first is we ask our validator, is the field complete? Does it have the correct number of digits or characters? If so, we then ask our validator to validate that field. And if it's valid, we then use the Android native library to find the next focusable element and request focus on it. So now let's turn to the address fields. So by combining with various data sources, we're able to provide suggestions to the user on ways they can complete that address form as fast as possible. But we wanted to optimize it. So we have multiple data sources. We use the Google Wallet, previous data, as well as Places API. Now, with any auto-suggestion feature, you want to strike with multiple data sources. You want to strike a balance between the most relevant data to the user and the data that is fastest to acquire and show. And in our case, previous wallet data meets both of these criteria. If you're a returning wallet user entering a new credit card, for example, there's a good chance that your billing address will be the same as your previous credit card. And so by querying this data locally in memory using simple string comparisons, we can determine if you're typing the same address. If not, or if you're a new wallet user, we'll then go to the Places API. Now, this data is very rich. However, it is not as personal in that it doesn't include things like apartment or street number or suite number. Further, it requires network I/O and a round trip, so it's not as fast as doing local onboard memory. So let's see some code for this. So a lot of auto-suggestion is really done within the autocomplete text view. And this is a subclass of the edit text component within Android that has been a part of the library since version 1. The autocomplete text view component handles a lot of the logistics and pain that's caused by providing auto-suggestion results, leaving the developer with two simple operations. The first is to provide the results for a given query using the perform filtering method, which is run in a background thread, so you're able to do long long-standing operations like fetching data from the network, disk, etc. When you have the data, you then need to tell the adapter and the text view that that data is available. And you do that from the publish results. And this notifies the text view that it needs to re-render the dropdown with the appropriate selections. So we tried here to make the form as easy and friendly to fill out so that a user could get through it as quickly as possible. Now with more on how to make your applications faster and more secure, I'll turn to John.
Thank you, John. I want to start out by asking, how many of you have used a commerce application and encountered a loading screen that took a very long time to complete? And how many of you, after encountering that loading screen, either exited out of the application or never completed your transaction? A lot of you. As you look around the room, you could see that this is a major contributing factor to today's mobile cart abandonment rate. And today I'm going to provide some tips on how to make a good first impression on your users and how to improve the responsiveness of your application once a user has launched it. 125 milliseconds. That is the time it takes from when Instant Buy is launched to when a user can interact with it. There's no loading dialog. A user can select a shipping address. They can select a credit card. They can complete their transaction. We accomplish this by using a technique known as on-device caching. What you do here is you look for that data you're going to display on your first activity, store it on the device before your activity is launched, so that way the next time your activity is launched, you can populate the UI from disk and provide a very responsive experience for your users. Our team has found that caching data that changes infrequently is very good for this technique since it has low synchronization requirements. And more specifically, we use it for loading our chooser dialog with shipping addresses and masked credit card info that's shown when we launch Instant Buy. However, there are some challenges that come up with this technique. You need to know where you're going to store this information on the device, how often you're going to synchronize data from the cloud to the device, and how to handle any cache inconsistencies that may occur. With storage, if you're going to store any sensitive information about the user or your application, you need to make sure that only your app can read and write to this file. A popular place that people like to store info on the device is the SD card due to its large capacity. But any app on the device can read and write to the SD card with the appropriate permission. So you shouldn't put sensitive info there. Once you start synchronizing data from the cloud to your device, you need to be able to handle any merge conflicts that may come up. Think about how this is going to impact your user's experience if you're going to provide any messaging about what's going on. And then with synchronization, the frequency that you synchronize data from the cloud to the device really depends on your application and the freshness of data that your app requires. But you should consider how the synchronization strategy will impact your user's battery life and their network usage. These are limited resources on any smartphone or tablet, and if you abuse them, a user may uninstall your application. So now I'm going to dive into an example of a cache for shipping addresses using shared preferences. Here I've created an address store class. In the constructor, we're grabbing a handle to shared preferences. We're specifying context mode private. Since shipping addresses are sensitive information about a user, this makes sure that only my app can read and write to this file. Next, we have the getAddresses method. This will simply convert from the strings and shared preferences to address objects. Finally, we have the writeAddresses method, which will convert a list of addresses to strings to store in shared preferences. Here, I'm using the compatibility library for performing the write, so on newer versions of Android, it will be more efficient. So that's how to make your app, how to make a good first impression on your users. Now let's make a lasting one. So for this, we use the technique we call prefetching or pre-computing data. What you do here is you should look for instances in your application where you perform an expensive operation after an event or a user action such as a button click. Try and move these up earlier in the flow, perform them asynchronously once you know all the inputs, so that way when that event is fired, you can return the result immediately. Our team specifically uses this for prefetching auth tokens, so that way when a user clicks the submit button on the bottom of the form, we can just call the wallet servers rather than having to fetch the auth token and then call the wallet servers. And after doing this, we were able to reduce our latency by 30%. Again, there are some challenges with this technique. You shouldn't be using this for any requests that modify state about the user, such as adding a shipping address. These types of operations make modifications on data that is near and dear to the user, and doing it without their explicit consent or button click is not within their expectations. And second, a further optimization you can perform with this technique is what we call handling the pending state. Imagine you fire off a prefetch request, and then that event that requires the response is triggered while that request is ongoing. Rather than firing a duplicate request and starting over from scratch, you should wait till the prefetch request completes and return that result. This will further reduce the loading dialog in this case. So now I'm going to jump into an example of actually prefetching an auth token for a Google server. Here I've defined the prefetch auth token method. We're going to kick off an async task, call off to Google Auth Util to actually fetch the token. This will store the token on disk, so future calls will read from disk rather than hitting the network. And for those that are wondering, Google Auth Util is also part of Google Play Services and can be used for fetching tokens for things like App Engine. After that, we need to hook up the prefetch auth token method after our UI is displayed. And finally, we need to use that token. Here we're doing it in an on-click handler. We're going to fire off another async task, read the token. This time it should come from disk, and we're going to call our server. Now, some of you may notice that I don't have the pending state being handled on this slide, and it was just too much to fit. I will be sending out a full working example with the deck. So now I'm going to jump into some security and privacy techniques that you can use in your application. Security and privacy is one of those unseen user experience features of any commerce application. I'm going to provide some quick tips to make sure that you are handling your users' information more safely and how to maintain that trusting relationship with your users. So first and foremost, if you're sending any sensitive information about your user or your application to a remote server, this is something that all of you commerce developers should be doing. You need to make sure that it's encrypted, and we suggest HTTPS for this. If you don't do this, a malicious software or a malicious user could view this data over the network and perform fraudulent activities. Another thing you should consider is data that you're sending to Logcat. On pre-Jelly Bean devices, any app on the phone can read any other app's logs as long as they have the get logs permission. From there, they can send these logs to a remote server, parse out pieces that they're interested in, and do what they want. So our team uses ProGuard to not only optimize our application, but also strip logging. And the reason we chose ProGuard is it doesn't require any code modifications and can easily be done on release builds before uploading to the Play Store. This comes in 2 steps. First, you need to enable ProGuard optimizations for your application. This is done by adding this one line to your project.properties file. And second, you need to tell ProGuard which method calls to remove from your app. Here we're removing android.util.log, I, V, and D. And this is done by using this assume no side effects clause. When paired with ProGuard optimizations, ProGuard will treat these method calls as no ops and completely remove them from your app. So that concludes some of the tips that the Instant Buy team used for improving our users' experience and their safety. I'm going to hand it off to Jesus from the Fancy, and he's going to tell you how they wowed their users.
Thank you. So the Fancy is the place to discover and collect from crowd-curated catalog of unique and amazing things. Here you will find all these beautiful gadget, fashion item, traveling spot, and many more, and you can fancy anything you like. And when you find something you like, you'll want to buy and own them as well. So at Fancy, whether it's a $5 keyring, $3,000 watch, or even $3 million helicopter, You can buy them right inside our app. So my focus is to provide a frictionless experience from sign up to checkout. And the Google APIs has really helped us achieve that on Android platform. So I'm going to dive right into demo and show you how we did it. So let's start with sign in. So this is the first screen you see when you launch our app. So I'm going to show you how Google Sign-In works and press that button. So we were one of the initial partners to implement this, and the adoption has been so much faster than we expected. So one of the reasons must be this screen you see right there, because here you can see exactly what information of you we will have access to. And I'm just going to press OK here, but you can actually fine-tune all these privacy settings and really control your data. So you can see how this is great for users who are more sensitive about their privacy. And now you're signed in. So as you can see, it's fast, easy, it's very transparent, and it has other cool features like you saw this morning at the keynote, like over-the-air install and cross-platform authentication. And finally, users just tend to trust Google. So it's a great way to reduce friction from your sign-up process. And it also plays well with Google Wallet. So let's see if there's anything I might want to buy. Everything looks great, but this one looks particularly good. So I'm just going to open up the item page. And one of the exciting features we have introduced together with Google Wallet is this Buy Now button you see at the item page. As the name suggests, it will skip all the intermediate steps like cart page and goes right into the payment flow. So I'll show you how it works. Press this button. And very quickly, you will be prompted with this Google Wallet dialog, where your information already filled up from other services or Google services. And you'll see there's a little checkbox there. And what this does is you're saying you approve to use Google Wallet at Fancy for the future purchases. So you won't see this dialog again when you buy from us again. I'm just going to press continue. And you're already at the last stage, where you can see the final process, and you can press complete, and now you're done. So as you can see, from the item page where I decided to buy this, I only needed to tap 3 times to complete the purchase. And next time, it'll be only 2 taps. So that's very amazing. And the whole Buy Now button really works for us because we have great deal of single item orders, especially on Android. So we believe this will be a major way for our users to buy from us. And we are very excited. Now that I just bought something very cool, I want to brag about it to my friends and family. So I'm going to share it on Google+. So this is kind of opportunity you want to take advantage of to promote your app and create some word of mouth. And Google+ Interactive Post is really the right tool for this. Just going to share it right there. And go back to the slide and show how that looks. So every interactive post, they have something called a call to action buttons. In this case, it's a buy button. You can name it from the long list of button labels. And when you click this, it will actually link into our app and opens up the relevant page, in this case, the item page. If you do not have our app installed already, then you'll be taken to Google Play Store page, and where you can install it, launch it, and you can sign in, and you'll still be taken to the item page. And remember, this button is coming from your friends and family. So this is a very personal and effective way to promote your app. And we are seeing very high click rate of this button on Android. But the bigger picture I'm trying to show you through this demo is that with this tool, you can achieve a viral cycle where discovery converts into purchase with minimum friction, and purchase brings in more discoveries. Now we are going to share some other tips we have learned from our own experience at Fancy. We have very international user base. We have orders from all over the world. And here are some of the things you might want to consider for your international users. So most of you must be used to the form where the country is placed at the last after the state box. But really, you want to reverse them because state box actually depend on the country. So if you have United States selected, it'll be a usual drop box with state. And if it's Canada, you'll be prompted with Dropbox with list of province. For some other country, maybe you'll want to fall back to a plain text box, which can be optional. And postal code, it looks easy, but I made a mistake of assuming they are always number. And I made our postal code box number only. And turns out some countries like United Kingdom or Canada, they also use letters. So I actually prevented some users from placing an order from us. So you do not want to make the same mistake. Now, you of course want to localize your app for your international user, but you have to remember, once you do that, people will start to enter their addresses in their languages. So make sure your apps, your backend code, and even your logistic teams are ready to handle them. Finally, we found out it's a very good idea to predict users' country and present that as a default. It sounds minor and trivial, but it's not just about eliminating the pain to go through hundreds of countries just to find your own, but it's also about sending out a message that you are able to handle their orders correctly. Because when I buy something internationally, I tend to be cautious and I get worried, like, do they even ship to my country? Or what about the import tax, stuff like that. But when I see my country selected, when I open up the form, it gives me a certain degree of confidence. So there are a couple of ways to do that. The most accurate and easiest way to do it, fastest way to do it is pull it from the carrier using this class called Telephony Manager. It's accurate and fast, but it's not always available. Like a few carriers or Wi-Fi only devices, you won't have this information available. So make sure you fall back to the local setting, which is linked to your language setting, so it won't be always accurate. But it's always available, so you can fall back to that. If your app happens to be using users' location info for some other reason, you could also use that. And you could also do the geo-IP lookup. So now that on mobile environment, you know that even a single button click can cause a significant latency and friction, you want to avoid that as much as you can by predicting what user is going to do only. One obvious example is payment and shipping address, because you know they will use the same one in most cases. So you can pre-calculate tax and shipping and show that at early stage, like cut page, and you can let them pay with their last credit card without going through additional steps like payment page. Of course, they should be presented with a chance to change it at some point during the process, but my point here is that you do not want to make your users move their finger just to do something you can anticipate. That's it from me, and I'll hand the stage back to Jean.
Thank you, Jesus. We're very excited to work with Fancy on integrating Instant Buy into their application. It's available today on the Play Store, and I encourage you to check it out. It's very cool. There's some very unique items on there. So let's wrap up. Today we discussed how using Google Wallet Instant Buy can improve conversion on your site by eliminating or reducing a lot of the pain that users experience in checking out of payment applications. We leveraged a lot of cool mobile-friendly form technology, such as real-time formatting, instant validation, auto-advancing form fields, and input suggestions. And these are things that you can do in your own applications as well. Further, we mentioned how on-device caching and pre-computing and fetching data before it's needed can help with that first impression on the user's mind, as well as their lasting impression as they use your app and learn to love it. We also stressed how handling user data safely is a very large concern because it instills a degree of trust in your users that encourages them to buy with your applications. Jesus mentioned how leveraging the Google Plus sign-in has helped Fancy with Android developers, signing them into the application and getting them started. He also mentioned a number of international tips that you should be aware of to be more accessible in international markets. So where can you go from here? You can sign up for Instant Buy at getinstantbuy.withgoogle.com. There will be an Instant Buy Code Lab on Friday at 9 a.m. with our colleagues in which you'll go through the integration process of Instant Buy into a sample merchant app. Also, there will be wallet office hours and a developer sandbox on the second floor, In addition, Fancy will be at the Google Plus Developer Sandbox, also located on the second floor. And again, I encourage you to check out Fancy with Instant Buy on the Play Store, available today. So thank you very much. I'll now invite our product manager up, Prakash, to help answer some questions. Are there any questions?
Please go to the mic.
Oh, and please go to the mic if you have questions. We got one.
Just wondering if this works on the mobile web at all? Is this strictly
So does this work on mobile web? I think that'd be
So we have a similar solution which has been public. You can go to our developer page, and essentially we have Instant Buy for mobile web and apps. What we announced today was Instant Buy for mobile apps. Instant Buy for mobile web has been live since last fall.
Okay, cool, thanks.
Yeah, we're always having to be cognizant of accessibility, and I was wondering with your auto-advancing features, how does that play with accessibility?
So how does auto-advancing play with accessibility? Can't go to Prakash on this one.
Okay, so essentially I think basically with the auto advancement, because it's very intuitive, it's less input required by the user. It basically guides the user to a flow, so it helps with the accessibility challenge, if you will.
Does it like announce the fields as you march through them, or allow you to read back what you've entered? I can't see, and so I've just entered a credit card number, and I need to be able to validate it. Validation errors, do they get read? I'm just wondering if that's something that you have to roll yourself, or how that works.
Yes, as it progresses through the form, it will read out the description of what the field is based on the hint text. And if there's an error that comes up, it will also speak what the error is.
Cool, thank you.
Any other questions? All right.
Great.
Well, thank you all for coming.